Alright, so putting the crankshaft in the little M10 motor. Just want to show you all a few little pointers, stuff that I do whenever I'm putting the engine together. So this is the crankshaft. We're going from a 1.8 liter stroke crankshaft to a 2 liter, so kind of like a little BMW stroker motor, I guess you could say. I always put all my upper main bearings in the block first. Then I put a little assembly lube on them. The reason why I do that is if I put the crankshaft in and everything's happy, all my specs check out, then I don't have to take it all back out to put assembly lube to put it all back together. Now, if something doesn't come out right and you gotta take it all back apart, it was a moot point, but it could save you some time. So there's a couple of different ways to check your bearing clearances. The first way with a lot of tools and everything is to put your bearings in the block, put your bearings in the main caps, put everything on, torque it all down, and take a snap gauge and measure your diameter of your mains. And then you come back and measure the diameter of your crankshaft journals, and then subtract the two, and that'll give you the difference between the two, and that's what your clearance is. Another way to do it, which is it requires less tools. Some people say that, it doesn't work. Man, I tell you what, if you do it right, it can be a very helpful tool to help make sure that you get it right. It's what the industry calls Plastigage. It's literally a little piece of plastic that you lay, you put your mains in, your main bearings in, you put your crankshaft in, and then put all your main caps on, but you put them on dry with the bearing. Don't put any assembly lube. Torque it all down, and then you go one by one, putting a piece of Plastigage on the crankshaft. Then you put your main cap on that, torque it down. Now you have to make sure that all your other main caps are torqued down, because if you don't, you'll have a crankshaft that can be, kind of out of alignment. So when you torque it down, it squishes that plastic, and depending on how much that plastic squishes out, will tell you how much clearance you have between your crankshaft and your bearings. I like it because it is a physical measurement. You don't have to worry about, oh, did I screw the math up? If your Plastigage smushes all the way out, and like you had no clearance at all, and your crankshaft doesn't turn, you know something's not right, something's too tight. If you put it down and the Plastigage never got crushed, well then you know something's not right, and you have way too much clearance. So this is what the Plastigage looks like. It comes in a little piece of paper, and it's a little green piece of plastic that's in there. And all you do is find out how much you need, the width, and you're going to lay it across your bearing surface, and then you just tear it off. So I want to get me about, I don't know, maybe an inch or so. So I'll come right here, I'll tear it, and so inside of here now has a little piece of plastic. You can come closer, Jonathan, things are going to get a little close up. Got to watch it because this stuff will fall on the floor. If it falls on the floor, it gets dirty, I would throw it away, get another strip, or the wind can take it. It's just this little plastic strip. That's all it is. So I'm going to take this, I'll place it right on the bearing surface that I want to measure. Now, you got to make sure everything is very clean. Any oil on it will cause that plastic to start to melt, and you'll get some really obscure readings. Dry and clean is the way you want to do it. Now, this is your bearing cap right here. If you ever take your bearing caps off, always try to number them before you take them off, so that way you know what sequence they went in. If you put them back in the wrong spot, your clearances are going to be incorrect. When they put these caps on in the factory, they run a line home through the block to really get the surface right here where the cap meets the block to be perfectly true. If you start swapping them around, that surface is not true anymore. You'll have a crankshaft that's going to lock up, it's going to get eaten up, it'll destroy itself very rapidly. You always want to make sure you put them in the correct orientation. You don't want to take it off this way, turn it around, and put it back the other way. Same reasons. Your machining tolerances are not going to be there. You can definitely tell if you have them flipped around. If you look on this little cap right here, they have that slot. The block also has the same type of slot. On every engine that I've ever built, those slots have always been on the same side. I'm not saying that there's some manufacturer that has put them on the opposite sides, but just from my experience, every motor I've ever put together, it's always been on the same side. Your bearing has a little register that fits in that slot. I don't know if you can see it. You don't want to put any lube on the backside of your bearing. It does no good because that part, it shouldn't be moving. If it is moving, you spun bearings, everything's bad. So anyway, you want to take your main bearing. Go ahead and snap it in place. Make sure your bearing surface is nice and clean. No oil. Make sure your tabs are on the same side. Make sure your Plastigage hasn't blown away with the wind. Take your main cap and set it on. Different manufacturers recommend different lube for your threads on your bolts. BMW says just use engine oil, so I'm just going to take a little bit of BMW's finest twin power turbo oil. You don't have to like drown them, just enough oil to lubricate the threads. If you put too much oil, the oil will leak all over the place and kind of get on your crankshaft and can screw up your Plastigage reading. I like to put my caps on, start the bolts by a couple of threads, then I'll take my cap and I'll tap it all the rest of the way in place. The reason why I like to do that, if you try to screw it down with the bolts, sometimes you can get the cap cocked and then like put it in a bind. I found that just by taking that, tapping it down the rest of the way, your bolts are going to go on nice and easy, and it just won't fight you as much. I don't know if you could like chip a cap by putting them on a little crooked. I've never experienced that. I guess it could be possible. And then you're going to want to torque them down. You don't want to torque one side all the way down to the torque spec and then the other side all the way down. You want to take it in steps. This torque spec on these main bolts are 60 Newton meters, so I'll probably do 20 Newton meters, 40 Newton meters, 60 Newton meters. It's nice when you have a digital torque wrench. It shows you your live data basically, so you can see how much torque you're applying. Get them both snug. And Jonathan, if you want to look over here, you can see how much torque I'm applying. So I'll do 20, 20, 40, 40, 60, 60. Now, another thing you want to make sure that you do not do not rotate the crankshaft at this point. If you rotate the crankshaft, it'll smear your Plastigage, and the readings will be all kinds of wrong, and you'll be scratching your head figuring out how you messed up all your clearances. So you go ahead and take it back off. And now our Plastigage should have smushed down and given us an accurate reading of how much actual clearance we have. All right, so if you look right there, that's our smush. That's how much spread we have. Now, on the back of the Plastigage, it has the way you check your clearance. So if it smushes out a bunch, you have 1/1000th of an inch, a little bit less, 1.5, and so on and so forth. So you can take this little gauge, hence Plastigage, and set it right here. And we can see that we're in between 1.5 and 2/1000. So not quite as thick as smushing out for 1.5, not quite as thin as 2/1000. So that gives us our clearance of between 1.5 and 2/1000, which is right where I wanted this little motor. There's a lot of things that affect bearing clearances, how much you want to run, how much you don't want to run. Typically, very high RPM motors, they'll tend to run them a little bit looser. Motors that have very large bearing surfaces, like a 351 Windsor has really big main bearings. They tend to run those a little bit looser because you have more thermal expansion going on. Oil viscosity. If you intend on running a very thick oil, you'll run some larger clearances. And when I say larger, look, we're talking about anywhere from 1/1000th on a really tight side, all the way up to about 3/1000ths on the loose side. So I mean, it's not that much of a difference when you're looking at the physical aspect, but when it comes down to it, that 1.5 surface of oil that you're riding on really makes a big difference. The thinner the clearances you go with, typically the thinner the oils you run. A lot of the modern cars are starting to run these 0.20s and stuff like that, so they'll start tightening up those clearances so that way the viscosity of the oil can work with those bearings. Now, your Plastigage is on there. How do you get it off? A lot of people will sit there and try to wipe it and rub it and all that stuff. I found out that WD-40 really works well at getting it off. So just take a little good old WD-40, spray it on it, let it soak for a second. And Plastigage, it dissolves in oil. So that's it. Plastigage is going off of that. Do one more little spritz. And that's it. Just like that, the Plastigage is gone. The WD-40 poses no risk to the engine. So now that I'm satisfied that my bearing clearances are adequate and they're right where they need to be, my top side of my bearing shell, the one that goes in the block, it's already lubed with engine assembly lube. The engine assembly lube basically gives it lubrication for its first initial startup until the oil gets to it and starts lubricating things after that. It's very important. You don't want to start it dry because any metal-to-metal contact really goes bad fast. So this Royal Purple Max Tough has worked out really good for me. It's not as pasty as some of the other ones. I don't know if I would use this on an engine that I'm going to build and let it sit on a shelf for a year, but definitely for an engine that I'll be building and firing up, put it in the car right away kind of deal, it works out really, really good. It hasn't given me any issues. Go ahead and put a little lube on the bearing. Make sure your caps, your little gaps line up on the same side so you don't get your caps crossed. Give it a couple of threads to start. Knock the cap down until it seats. And you can screw them the rest of the way. Now all of these are already torqued. I had checked each one by one, already went through that process, but you want to make sure that all of them are torqued and then take them loose one at a time to Plastigage and check them. Again, that'll keep your crankshaft in the block sitting straight, because if you don't, you could have the crankshaft sitting, up on one side or the other, and it'll definitely throw your readings off and give you some grief. Again, going to take it in 3 steps. $20, $40, $60. Now, this is in Newton meters, not foot pounds. Don't mix up the two. Don't crisscross them, because foot pounds are a lot higher than Newton meters. So if you torque something to 60 foot pounds rather than 60 Newton meters, the difference is quite dramatic, and you might get past the stress point of your fastener. Last thing I want to show you as far as putting the crankshaft in, you're going to want to look at your crankshaft in play, meaning how much room the crankshaft has to move front and rear of the engine itself. If you have too much in play, it'll cause oil pressure issues. If you have not enough in play, you'll have clearance issues where you'll lock a motor up and destroy a bunch of stuff. This engine, one of the reasons why I took it apart is because it had way too much crankshaft in play. Typically your specs on the low side will be like, the lowest I've really seen was about 3/1000ths, maybe 2, but you're starting to get real tight. The loosest I've seen is like 8/1000ths. Once you start getting beyond that, you really start getting too much front to rear in play. This engine had about 20 thousandths of crankshaft in play. Whenever I took the crank out, the surface that the thrust bearing rides on was damaged beyond repair. So that's why we needed a different crankshaft. That's why I decided to go with the 2 liter instead of 1.8, because if I'm going to change a crank, displacement, there's no replacement for it. So anyway, the bearing that controls the front to rear movement of the crankshaft is called a thrust bearing. BMW on the M10 put it right on the middle main cap. The bearing looks a lot different than the other ones. The other ones are just a bearing that's just a little saddle, and that's it. The thrust bearing, actually, it still has a saddle, but then it has some little pieces of it that go on the outside of the cap. And those little pieces are actually the bearing that keeps it from moving front to rear. So the way that you check it is, you take a dial indicator, put it on the end of the crankshaft, doesn't matter if it's the front or the back end. You want to make sure your dial indicator is true with your crank. You don't want to have it like at an angle because it will give you false readings. So you take your crankshaft and you push it all the way to one side or the other. So I'm going to take this one, and usually just a good flat screwdriver, pry bar, something like that. And you can just, it doesn't take much, just pry the crankshaft to put it all the way to one end of the engine. And then you zero your mic, or your dial indicator. So we're at 0 right now. Now, I know the crankshaft is pushed all the way back, so I'll take it and I'll push it forward. And Jonathan, if you watch this right here, we can get them. So that's our clearance right there. So we're at 0, and we've got about a hair over 4 thousandths, which is perfect. That's the sweet spot. I really like that. When you put that thrust bearing on, Plastigage it, do all that stuff, get those clearances proper, and then whenever you put the cap back on, before you torque it down, like you put the cap on, tap it back in place, run your bolts all the way down, and before you torque them, take a little dead blow hammer and hit your crankshaft front and rear. Like just hit it, good old pop to the front, pop to the rear. What that's going to do is it's going to true up that thrust bearing. Because if you have your thrust bearing, there's your bottom half, here's your top half, and let's say the cap is a little over, it'll give you some skewed readings because your caps aren't lined up. By bumping the crank front and rear, it lines the cap and the block side of the thrust bearing together and gives you your true reading. After you've done all that, if everything worked out right, you should have a crankshaft that turns over nice and smooth. If you have a crankshaft that starts to get hard in one spot or bind up, you know that you have an issue, you know you need to start rechecking things. I did have one time that it would roll nice and smooth, and whenever it got to a certain spot, it would get hard. And I was like, man, what the heck is going on? And so I rolled it over to the hard spot and put my dial indicator on it, and it had 0 front to rear movement. So that right there told me that I have a thrust problem. So, but anyway, so it's all together, and this crankshaft turns nice and smooth, has a little resistance due to the assembly lube, but I mean, you can turn it with one finger, and that's putting a crankshaft in the block. I'll come back in a little bit and start showing how we gap the rings and put rods and rod bolt stretch and all that stuff. But for now, here it is.